Ever feel like there's a better way to build? So do we. I'm Matt, and welcome to the Mindful Builder podcast, where we believe in education through storytelling. Join me and my co-host Hamish as we both have a passion for building better, breaking barriers, and sharing our experience within the building industry. We're not pretending to know it all. In fact, we're learning right alongside you. Join us each week as we tackle complex topics like building science and mental well-being, inviting the brightest minds to connect curiosity with expertise. We want this to be a real conversation, encouraging vulnerability through honest discussions. So if you love this podcast and you're ready to join in, learn and build better, please do us a favor and subscribe wherever listening. It's the best way to make sure you never miss an episode, plus it really helps us out. And if you're feeling extra generous, a 5-star rating and a quick review would be amazing. Your support helps us reach new listeners and, even better, allows us to book incredible guests for the future episodes. Thank you so much for being part of our community. We truly appreciate you. And now on to this week's episode. Daniel, who are you?
I'm an architectural engineer. I build robots that build concrete things and do it in a more sustainable way.
All right, great. Thanks for coming.
So what do you mean? Do you build the robots or you create the concrete?
Both.
So so while you were outside on your phone call before, Matt, I had a really interesting conversation. So obviously, I like to think of myself as a sustainable builder, and my ears sort of perked up when Matt said I've got someone who's making low carbon concrete. So I reckon let's start there and maybe just explain to the listeners, like, what is it you do? Like, I've been using EcoPact concrete from Wholesome for a number.
I did my house just recently
for a number of years and have been really happy with it. And I think it's a fantastic product. It's now specified on all our jobs, but yours is a little bit different.
Yeah.
Could you tell us a little bit about?
Yeah. So we've developed a low carbon concrete, which is a geopolymer. It's what we call it. It's used as waste byproducts that replace the cement, which is the polluting part of the mix design for standard concrete. It is a geopolymer that achieves 50 MPa grade strength for precast applications. So we're focused on the precast market, and Curvecrete is positioned in a way where we can then scale up our material to be utilized on infrastructure projects for noise walls and earth retaining walls and that sort of thing. And that's part of the reason why we're here at ArchiBuild.
Right. And when you say, like, they're quite specific projects, where Matt and I are from, like, a residential point of view, but you're talking about, like, I can imagine, like, I'm driving down the Eastern Freeway and I see these big walls which are trying to stop noise transmission. Is that the kind of stuff that you're talking about?
Yeah, that's right.
Yeah.
And so the noise walls is our big ambition to solve for freestanding wall elements that are 9-10 meters high. There's an abundance of them that are required for infrastructure around Australia. Here at the Big Build in Victoria, there's noise wall elements that are currently being created that are 300 millimeter thick flat elements, 9 meters high, 300 millimeters thick. There's a couple of innovations that I have to explain here. So that's the benchmark, 300 millimeters thick, 9 meters high. With the technology that we developed at Curvecrete, there's the low carbon concrete, right? So if we created one of those panels with our low carbon concrete, it'll avoid 70% of the emissions relative to standard concrete. But we also developed a robotic method that creates curved concrete elements. And the curved concrete elements are naturally much more stiff in their geometry. So you can use curvature to make the elements lighter.
Does that mean you can make them thinner?
Thinner, yeah.
And does the curve actually help with that sound deadening? And
it can help with the scattering effect of sound, yeah, for sure.
Yeah, but that's not the primary reason why you're.
That's a bonus.
That's a bonus. Yeah.
Cool. So the curvature enables a more structurally efficient design. It means the panels can be 150 millimeter thick instead of 300.
Wow. I didn't know. So curved concrete is stronger than straight concrete.
Yes.
That's now. Why is it?
Concrete's really good in compression. So if you have a flat everyone can do this exercise at home, with a piece of paper. If it's a flat piece of paper, it's floppy, If you fold it, it becomes a little bit more stiff. Or if you curve it, it also becomes stiff.
That makes sense.
Right?
Yeah.
Okay?
Yeah, okay.
Even though it's a thin sheet of paper. So you can use the same principle on concrete.
You talked about like this benchmark wall, that your comparative, that you talked about a 300 wide wall by 9 meters tall.
Yep.
And you're saying that your product is 70% less carbon.
Yep. In the material itself.
Yeah, okay, in the material itself. Okay, so it's not because yours are 150 mil thick. So there's obviously less material, so ultimately less carbon. But you're saying it's even lower because you can have less product and it's 70%. Yeah, okay.
Correct.
All right, cool.
All right, so we go to 85% less now.
Yeah, then a comparative. Yeah,
So 70% is within the product, and the rest is remaining the way that you construct.
Yes.
Yep.
Yeah. Okay. And are you reducing the cement through flash and slag? Or?
Correct.
Yeah. Okay. Cool.
Well, you're eliminating the cement because you've got
That's
a
right.
geopolymer.
I thought you can't eliminate 100% cement.
You can.
Yeah, because you're using a different. So while you're outside on your phone, we're talking about a company in Queensland called Wagner's, and they've actually got they're like
it's
you
a
guys.
geopolymer.
It's a geopolymer, and there's no cement in it.
So what's a geopolymer? Is it like a plastic?
No. There's common misconception because the polymer's in the name, right?
Yeah.
But the geo is what counts.
Yeah, okay.
Right. So the geo part of it is actually mineral substance. It's more like rock. It's usually a metal with a metal oxide with some carbon atoms attached to it and that sort of thing, or silica. So a geopolymer primarily in its chemistry is an aluminosilicate, it creates these sort of gels that are based on those materials rather than the polymers, which are hydrocarbons.
So it's like a more rigid, is it more fluid structure compared to a rigid structure?
It's very similar to concrete. It's rigid. A polymer can be like flexed and ductile, but a geopolymer is very much more like a rock. It's an artificial rock, just like concrete.
And so why is Portland cement then bad?
2 reasons. One is that you have to heat it to high temperatures, go through this process of creating clinker. That uses a lot of energy. But the second thing is almost unavoidable is within the chemistry itself, when you do heat it, it releases carbon dioxide in the process. And if you combine those 2 processes, they're 8% of all global emissions. So 4% from the heating of the cement and another 4% from the emission of CO2 in that chemistry process. Second most used substance on the planet to water is emitting,
Yeah, and the thing is, it's such a fucking good product. Like, it's such an amazing
We pour
material.
that much concrete. What do we pour the amount to build Manhattan per week? Is that right? Something
like
crazy amount of concrete. Like it's literally everywhere. You see them. So I want to go back. Are you a chemical engineer? What's your background?
My background, I put it mostly on my father as an electronic engineer who, from a young age, I got exposed to creating electrical circuits and things. Some of the toys that I made, a remote control boat. My dad didn't just buy the components that we could build the remote control boat. He showed me a design of a circuit for, radio receiver, and I soldered it myself and had to figure out the circuitry when I was about 13 years old. So I created my first circuit board there, and then built all sorts of things, always building things, furniture out in the garage, designing them, introduced to CAD, computer-aided design when I was 17 through my graphic design teacher at school. I was like, oh, this is cool, can do things in 3D, and had a passion for architecture. That put me on this journey in academia because I got accepted to aerospace engineering.
He's a real engineer. He's a real...
You're a smart cookie.
Loved math. That was...
What do we call Cam?
Rocket scientist.
Rocket scientist.
Real
Rocket scientist.
Anyway, there's a lot of history there, but in a nutshell, aerospace eng, civil eng, and architecture all sort of combined academically and helped found the architectural engineering course at Swinburne University, which I still lecture at and teach the the young architectural engineers, and we're trying to build, Australia's capability in architectural engineering, because that's where all the design integration and innovation happens in the industry.
Yeah. Could you maybe just define architectural engineering? Because usually they're split up. You got an architect and you got an engineer
who don't talk.
Yeah. Well, occasionally.
They talk loudly at each other.
Yeah. So what does that mean? So architectural engineer.
I'll name drop Simon De Silva, because he mentored me as a young lecturer at RMIT when I was there. And he used to say, as a building, you want to take this hand-in-glove approach, right? So the architecture is the hand and the glove is the engineer, or the structural engineering, and it's they should work as one. So the architecture side of it is all the human side of how you make buildings work. The engineering side is all the technology and stuff that makes the architecture function. And when you have all of that floating around in one brain rather than two separate brains, you can begin to sort of iterate in between those two things and set goals for the human aspects of the design and make the functional things sort of achieve that. So in a very general way, that's the way of thinking.
Yeah.
So within like Swinburne's architectural engineering degree, they learn structures, but they don't learn it from like using a similar approach to civil engineering. While they do the fundamentals and design a beam in isolation in some cases with the civil engineering portion of it, we teach how to design the entire building as a system, as a structural system that can be pushed and pulled and adjusted as the design iterates. Yeah. So then you can adjust it to the human requirements with light and heat and etc.
So you walk out as into this degree, are you able to register yourself on the architect board or an engineering board, or what?
It's an engineering board.
Okay.
So it's a fully accredited Engineers Australia degree.
So I was just thinking, because we've interviewed an architect today, right? And so there's a couple of thoughts running through my brain. First thought is, it's such a practical approach when you put those two things together, because there's synergy between the two.
Yeah.
I think one of the limiting things that come to my mind, though, is that you actually remove some of the creativity that architects then are allowed to kind of flourish in when they're not limited by the practical engineering side of things. Now, I'm not saying one's better than the other, because I think both have merit. From a builder's point of view, I love the whole architecture engineer thing, because
it makes so much sense.
It makes so much sense. But then I think if we hadn't talked to Danny today, I wouldn't have even brought this up. I love the fact that they spend 5 years at uni and they just say, just let your brain be free and create and do all those crazy things. I mean, I don't know where I'm going with this. It just happens to have been like these two thoughts that came to my mind then that both have merit. Both, yeah.
Well, we need architects to challenge engineers to create what needs to be created for society. I feel architects' responsibility to do that. I think sometimes they actually are maybe holding back a little bit with some engineers. Like you've got to keep the pressure on and get them to innovate. And really be comfortable with something that's more interesting.
And that's good, because everyone's kind of forcing everyone to step outside of their comfort zone. So then you get these amazing results. I mean, I love that you're kind of talking about that middle part, though, that the real practical space where everyone kind of comes together, and it's actually can be achievable. Because I think a lot of ideas just remain ideas, whereas yours is like the idea and the solution.
So the robotics part, talk to me about that. What is like, have you developed a robot that makes the formwork, or?
It is the formwork.
Hang on, the robot is the formwork.
Yes. Yeah.
Okay.
I'm confused. I'm confused.
Okay.
Yeah, so formwork wants to be rigid, right? So that's the challenge. But to just explain it, what are we doing? We're casting concrete, traditional casting method, right, into a form, but that form has multiple different shapes that it could be in. So essentially it's an adjustable or adaptable formwork, moves, different curved shapes.
Fucking brilliant.
So you're actually using, maybe I'm going to break this right back down. So you've got formwork that is a robot that will just essentially move to whatever you want the robot to hold itself as, and then you pour it.
Correct.
And the next time, like you take the concrete out, and then on the next pour, it could be different shape of that exact same bit of formwork.
Correct.
And that does not require any
And-
manual labor to make the formwork.
I mean, this is fucking genius because all you're then doing is telling the computer what it to be, and the robot's just doing that.
Yep.
Okay.
So could we then see formwork?
Is there an opportunity to invest in this company?
So you could essentially wipe out all formwork for construction
I'll
workers.
grab a term sheet.
Yeah.
So
Okay.
you could,
Please.
you could potentially
What's the minimum investment?
Could you wipe out all formwork construction labor in the future?
Yeah, I mean, possibly. So
In a controlled environment, I would say
Yeah.
there's an opportunity
So
for sure.
my mind splits in two when you ask that question, because technically, yes. But then commercially, how does that work?
I was going to say, because
Right.
if we do it
It's-
even commercial
yeah.
sector, that's one of the biggest
Yeah.
types of construction or trades on site is formwork.
Yeah.
I wonder how they're going to go if you're like, no,
Yeah,
we're going to cut
if-
all the jobs and we can do this. Because you could significantly reduce price, because we know labor is one of the most biggest
Well, if it's-
components.
if it's a company like Form 700 or Perry, formworking systems, like they've got their systems, right? And they're got to be marketed in situ, formwork. We could go into that.
Yeah.
What we're focusing on is precast at the moment.
Yeah, so you could wipe the whole precast. Sorry,
Yeah.
I should refer back. Change my comment. You could change the whole precast environment.
And, you can. You're
absolutely.
Not on site,
you're
yeah.
shaking it up. Like
Yeah.
you're disrupting it.
Yes.
So at the moment you're talking about like sound barriers, right?
Or even warehouses. Or,
Well, this is my next thing. Like, I mean, you're talking about the curvature allows you to make more efficient designs, but could you then apply that same logic to like a precast factory?
Yeah, absolutely.
Yeah.
So that's what we're doing now.
Yeah.
So we have our own factory in West Footscray. We're producing
we're
product.
in West Footscray. I mean,
Oh yeah,
That's
cool. Yeah, come by.
are you down
it's-
towards Tottenham way, or are you at the back end?
No, Tottenham.
Yeah.
Yeah, 500 square metre facility there. It's our prototyping facility actually now, but we produce product out of it. We're currently working with the M80 team on the Northeast Link to produce some earth retaining walls, which are actually on show here
I saw them. They're pretty cool.
today. I'll go into that in a bit more detail in a sec. But we're producing urban furniture. We're producing earth retaining walls. Yeah, we're producing product already. The noise walls, the bigger elements, that's where our ambition lies to go. And we're doing that in partnership with Advanced Precast.
Yeah. So I'd love to just know a little bit more about the mix. Like I just think about like how like concrete just work the concrete and they wait for it to dry to a certain point before they can start finishing and stuff like that. What is the process with your product?
Yeah, it's actually very similar.
So you are able to potentially remove steel as well from your your concrete, and then really reduce carbon footprint.
Yeah. So the challenge with us at Curvecrete is that we're continuously optimizing things, and we need to create that clear narrative of what we're doing. I haven't delved into that, so that's a really good question though.
Yeah.
But we've managed to demonstrate that you can actually eliminate a lot of the steel reinforcement in concrete as well by utilizing rock as the reinforcement, which sounds funny, but basalt is the rock that you can use when you melt down basalt and stretch it into long strands. You can create basalt reinforcement, and it's got a higher tensile capacity than steel. It's lower density than steel, so you end up with this compounding effect where you got about an 88% reduction in carbon emissions from the comparison of those metrics. So steel versus the equivalent strength in basalt Rio, 88% reduction in carbon emission.
What's the catch here? I feel like it's all too good to be true.
So
where my brain goes is like, but why isn't this now just like what everyone's going to?
Yeah, it's just a different way of engineering the system. So the standards since 1850, are steel reinforced concrete. Everyone's familiar with it. They get it.
Yeah, it's easy to come at. Yeah,
but you need some driving factor to change, like some significant driving factor for these types of concrete structures. In Canada and other regions where you've got freeze-thaw issues where cracks open up, basalt reinforcement is really, really good because it doesn't corrode.
Concrete cancer's gone, eliminated.
Yeah. So in environments like that, it's really essential to solve that problem.
Yeah.
So they use those types of systems. But here we don't have that issue as much.
So I just want to go back to the
basalt.
basalt.
We're introducing it.
I want to go back to the basalt thing because it kind of makes sense because mineral is
spun rock.
It's spun rock.
Correct.
It holds itself together.
So surely that whole process though is incredibly energy exhaustive. So like the actual like process of creating this basalt reinforcement is hugely,
Energy intensive.
Energy intensive. But what you're saying, just to confirm, is that it's less intensive than steel.
Yeah.
Okay.
Yeah.
So there's still some embodied carbon there, but
it's way less. Yeah.
How?
Because you can look at it as simplest perspective as just look at the density of the material. So density of steel is 7.8 specific gravity, whereas
I knew that one off the top of my head too.
Yeah, sure. Yeah, from memory, yes. Yeah.
Basalt's 2.7.
Okay.
So
Yeah. Okay. Yeah. All right. Well, you know what? Pennies drops now.
it's 2.5 times lighter.
Yeah. Okay. Right.
So then for lighter substance, less atoms. So less heating.
Yeah. Okay.
So does that mean, and that's assuming that you're not using renewables or something to create that too? Like if you had renewables, it's you don't need as much to get there too.
No.
Yeah, okay. All right. So we've solved all the problem now. We've got rid of Rio. We've got rid of Portland cement. So why isn't this everywhere?
I think the big challenges commercially are, well, how do you scale up these low carbon concretes where you have like a training overhead or some other different safety procedure or testing that's required prior.
Politics.
I mean,
Okay.
so the big cement manufacturers, Cement Australia and their people, their technical department's awesome. Like we chat to them all the time. Their sustainability department, we get along with them really, really well.
Yeah.
They're all really enthusiastic to do things, but then when it comes to getting it done, actually, it's a little bit slower.
Okay.
So what we've done is we've looked at, can we work with independents and start to...
Like a Wholesome or like a Boral or something like that, or even...
No, smaller.
Okay, even smaller again.
Yeah.
Well, mate, Wholesome's global.
Yeah, Wholesome actually, in Victoria, they're like not like, I think Pronto's the biggest in Victoria.
Yeah, but Wholesome is a global company.
Yeah, yes.
Yeah, so...
so is Boral, actually.
Yeah.
Boral as well, yeah. So, and Heidelberg Materials or Hansen. We work with them, we work with, master builders and Sika and these sort of producers of raw material as well. Like, it's all pretty collaborative, but then when it gets to the large commercial scale, it's quite difficult to navigate. So the best that we can do is demonstrate that it can be used, get specifiers to specify these types of new materials and put pressure on the industry at large to use it more.
And is that the reason why I guess you're then targeting, like I would see that the sound infrastructure is a product.
Yeah.
Is that why you've kind of targeted that at this point in time? Because then there's a proof of concept?
That's kind of like a North Star product.
Okay.
So we worked with Arup as well, I should mention.
Yeah.
They helped us a lot with engineering the system to the point where it can be specified. So they proved out that we could reduce the material by half, and have all the reinforcement detailing and everything.
There seems like there's a lot of red tape that you got to go through.
Yeah.
My mind immediately goes to, well, why aren't I pouring this concrete next week in my residential slab?
Yeah, and that's where my brain why
I'm just like, why aren't we just doing this? Because if you just sitting with you now, is enough for me to go, right, well, that makes all the sense. But I guess if I think about all of the infrastructure that's around us at the moment is purely based around that using Portland cement. We've got plants, we put it in the back of a concrete truck, and then we deliver it to site. Like that network's already there and existing. I'd imagine it would be like, because the opportunities for you guys are endless. Like
Like, why isn't all this is why I've asked the question before. Like, why don't they just get rid of normal concrete and just only use low carbon concrete?
Well, I'd said this I was just saying this, before you came in, Matt, that, I drive past that, where that main hub of all the buzz is with this new tunnels and links that that we've got at the moment. And there's a borrel plant right in the middle in Bulleen. And I had a thought the other day as I was driving past, and I thought, I wonder why they're not using low carb concrete on all of this concrete infrastructure that's going in. And I guarantee that it's not happening. It's just the same old stuff.
Yep.
And why is it not mandated that it's low carbon? Because there are tons, like tens of millions of tons of concrete that are getting putting in there.
It actually really frustrates me. It's just like, just roll with the new one, because once you have more like supply of it, the cost comes down.
Exactly.
Like it just we just hate that. We're just going to make that one obsolete now because it's outdated. We've got a better technology.
Are you just targeting a product? And in my mind, a precast panel is a product, rather than going, all right, well, we're going to try and target every single plant that's out there and have their trucks filled with our concrete. You're like, we can provide you a solution. Here's the solution for this problem, and it's quite specific. It's a precast panel.
Yeah.
Do you think that that's easier for you guys to focus on?
Yeah.
Yeah. Okay.
Yeah.
But ultimately, your market is infinite.
Yeah.
Like, we could use a seed in a slab.
Yeah. The challenge that is faced with these things, to be real, is that if you've got a in situ concrete supplier that deals with concrete and they're just churning it out, they've got their supply contracts, they've got, they know how to work the material, these sort of things. They don't have training overheads and these sort of things. So, there's a training overhead.
It's the same concrete. Like, we've used it. My concrete, I reckon, would have no idea about the difference.
Yeah, but I see where you're coming from, though, because there is that. There's a real fear. Change here that needs to happen.
It's the unfamiliarity of it from the specifier's perspective. I think that it comes down to. So I'm in the nitty gritty of how do we inform concrete suppliers about not using cement at all, and also educating the specifiers at the same time to say you can specify this. You don't have to specify just standard concrete. If it gets too far in that design process or specification process, and then the alternative comes in, that sort of consultancy overhead, doesn't exist on projects. So the money doesn't get spent on trying to change something. It's just, it's already done. So there's two angles that we have to attack, essentially.
So, maybe, I don't know if dumbing down's the right term, but
sure.
Dumb it down. So if, hypothetically speaking, your product was taking the place of Portland cement, and is that the component in the mix that you're replacing?
Yes.
Okay, so remove Portland cement, input yours into that supply chain. So two-part question. Does the rest of their infrastructure and delivery of it change, or is it the same?
The infrastructure slightly changes because with our mix design, you're using slag and fly ash rather than cement.
Yeah.
So, some batching plants might have, just a silo for cement.
Yeah.
Maybe just a silo for, fly ash or something.
Yeah.
Maybe they need to introduce another silo for the slag.
Okay. And this is what I was getting at before, because there's all those costs as well.
So it's investment from the plant.
Exactly.
But then you go back to your Borrell comment where they've just made one on the new freeway. Like, why isn't it just like, that's what we're making?
Yeah.
But then, if you give the example, like we've been doing a little bit of back and forth with GeoQuest up in Albury, their Hanson facility, or Heidelberg Materials facility, that has cement, slag and fly ash there already, but that was because GeoQuest sorry Hanson, but GeoQuest pushed them to put it in there because they really want to do it. So the pressures from precasters or other builders potentially, and in situ concreters, if they pressure the raw material suppliers to change their facilities, they'll change it if the demand is there.
Yeah.
Right?
Yeah, okay.
And so we're here to like build that demand.
Yeah, okay. So you're now creating demand. So my second question is, if there's this demand and magically tomorrow everyone's like, well, you know what, we're just going to be using your concrete. Do you have the supply chain for it?
Yeah, I mean, yes.
And in my mind, and I'm assuming this is like a synthetic kind of. So you've got the fly ash, and then what your. I know you can't talk about your special sauce.
Oh,
the
secret sauce.
The secret sauce. So is that like just easily manufactured?
Yeah.
Yeah. Okay. Well.
Yeah. Okay. So it's no brainer. Now we need to wrap this one up. So
yeah.
This is exciting.
Yeah.
This is exciting.
I had an announcement, by the way.
Yeah. Go. What's the announcement?
Breaking news now.
So
breaking news.
Yeah. Breaking news. Literally just got an email a couple of hours ago from my patent attorney. And the patent that we were applying for our robotic technology, the adaptive mold, after 7 years, just got granted.
Congratulations.
Wow.
So there's a certificate there.
I mean, you can
certificate of grant.
You can show it to the...
That is...
You can see that.
That is pretty cool.
Wow.
There you go.
Geez,
we're
dropping
all the bombs here. Jackie Falgate.
That's unreal. Hey, look, I'm excited. You know what? I guess, like, just broadly speaking, like, I'm excited. Right now we're surrounded by a pretty innovative product, even though it's been around forever. DuraPanel. We're talking to you now of a low carbon concrete. For me, I don't know, concrete. I love it and I hate it at the same time. Like it
solves the problem that we have concerns with.
Yeah. It's there forever. This, for me, I don't know. This is the future. It's amazing. Well done.
Yeah.
Thank you very much for coming, mate.
Cheers.
Cool.